flux. So that is the reason there are two main effects of the armature action. So one is cross magnetation, other one is demagnetation. In even we discussed the natures of the waveforms. So the main field flux, I'm giving more importance to these points so that it is highly asked in the competitive exam. So I just want to miss any, I just want you to miss any points here. So that is the reason I'm explaining this. So this is the main field flux nature is in the trapezoidal wave shape, and armature flux, it is in the triangular waveform. And we have discussed in detail why the armature waveform in the triangular wave shape, and armature flux it follows the armature MMF in the polar region, and under the non-polar region the flux reduces here. So it is the formula depends upon the phi equal to mmf by s. Under polar region, phi is proportional to mmf. Under outside the polar region, phi is inversely proportional to s. So that we get a peculiar waveform, and the nature of the waveform is we call it as saddle shape waveform. And by combining the armature flux and main field flux, we got it is the resultant flux. The resultant flux nature is a peaky waveform. The resultant flux wave nature is a peaky waveform. So we will try to see this which portion. I think I have covered this topic. Let me try to be more clear once again. So for those who felt that it is a little bit difficult and who didn't understand clearly, so try to listen once again. And yes, okay. Now here we have discussed that if there are z number of conductors in the armature, you can see the cursor. Out of these conductors, we have seen that there are two effects of the armature action. Due to the armature flux, there is a cross magnetization and there is a demagnetization. Cross magnetization is nothing but the flux waveform nature is changing. Yeah, I'll try to show you that. The flux, instead of the horizontal waveform nature, the flux waveform is shifting 45 degrees or 50 degrees. Then this we call it as cross magnetization effects. And this cross magnetization is due to the armature flux. And second effect, I said that it is a demagnetization effect. Demagnetization effect is nothing but there is a net amount of reduction in the armature flux. Now we will try to see that which portion of the conductors are leading to the cross magnetization and which portion of the conductors are leading to the demagnetization. Okay. So if I ask you that in a class of 60 or in a class of 60 members, which portion of the students are above average, which portion of the students are below average, so I can be able to segregate that. In the similar manner, if for a total conductors of Z, then for a total conductor of Z conductors, so which portion of conductors are making the influence of cross magnetization and which portion of conductors are making an influence of demagnetization, that I'm going to see here. So as we assume that the total mechanical angle is 360 degrees, and we have explained in detail. Any queries? Okay. Any queries, you can use a chat box. Okay, and you can raise the question so that I'll try to answer. I'll try to repeat or I'll try to answer that accordingly. Now here we discussed that by using the right hand thumb rule. So we by using the Fleming's right hand rule and right hand thumb rule, we got a conclusion that so the conductors under the North Pole. So I hope you are maintaining your running notes. I hope you are maintaining your notes, and this will be very much helpful. So even in the further cases also. So yeah, I'll try to make a conclusion that the conductors on the North Pole, the current will be inwards or entering, and conductors under the South Pole, the current is outwards. Current will be outwards. The conductors on the South Pole, the current will be outwards. Okay, and which is dot symbol. Now, when the load is applied due to the effect of MNA, when the load is applied due to the effect of magnetic neutral axis, there is a shift in the MNA axis. Previously, the MNA and GNA are GMNA and GNA are lies in the same line, same axis. But as the load is applied and there is a shift in the theta, which we already discussed in the MNA and GNA axis. When load is applied, MNA axis shift towards the right side in case of generator. And how much amount of shift that is there, that is proportional to the theta. So if I applied 1/4 of load, and corresponding to the 1/4 of load, theta angle will be shifted. That is 20 degrees or 30 degrees of angle will be shifted. 20 degrees and 30 degrees of angle will be shifted. Okay, so 20 to 30 degrees angle will be shifted, and that's what I am represented here. And this line separates the magnetic portion between the north pole to the south pole. I am explaining step by step. I hope if you try to listen carefully, then it will be easy for you to understand. So this is the north pole. This MN axis separates the magnetic region between the north pole and south pole. Previously it was straight. Now it is shifted by an angle of theta. Now with this separation of axis, now to the left side of MNA, the portion covered by the north pole. To the right side of MNA, the portion covered by the south pole. Now you can see that previously the conductors here also, the conductors which are placed here also, it is north pole. It is north pole, and here the conductors here also placed under the, it is under the influence of south pole, which is dot symbol. But due to the shift of this MN axis, this conductor current direction will change to entering instead of leaving. Now, and again here previously this conductor is under the influence of north pole, and the direction of current is entering. But as the MN axis is shifted, and this total left side portion is north pole and right side portion is south pole, now the current direction will be changing to outwards or leaving direction. Current direction will change to outwards or leaving direction. Yeah, this is the first conclusion that I would like to say that. I hope someone unmuted. 89. Don't worry, I'll mute. Any queries? 89, you can ask me. If you have really any queries, you can unmute and you can ask me. Other than that, if you have made a okay.
Sir, nothing, sir. There is a network problem.
Okay, yeah, you can mute now. Okay. Yeah. So now we'll try to see this. So this is what we discussed that. So here with the shift of MN axis, the MN axis will divide the magnetic portion, the conductors covered by the north pole and conductors covered by the south pole due to the shift of MN axis. So previously the conductor which the current direction is leaving, now the current direction is entering, and similarly which the conductors are entering, now the current direction changed to leaving here. Now we will try to segregate what is the cross magnetization, which portion of conductors are cross magnetizing effect and which portion of conductors are leading to the dot magnetization effect. Now if you can see this, now you can try to see, you can observe the cursor. Now I'm considering this portion of the conductors here. So the dotted line represents that MN axis towards the generator side, and corresponding opposite dotted line represents that MN axis in the direction of generator. MN axis in the direction of generator. It's like a X symbol. It's like a X symbol. Now here I'm dividing the armature into 4 portions. Try to observe clearly. I'm dividing the armature into 4 portions. You can see the closed dotted lines. That 4 closed dotted lines represent the 4 different areas. 4 dotted lines. This is 1, and this is 2, and this is 3, and this is 4th one. So okay, 1, 2 corresponds to the 2 different portions, and 3, 4 corresponds to the 2 different portions. Now let's try to see this. So how it is going to affect it. Now you can see this, as we discussed in detail. Here direction of current is inwards. If the direction of current is inwards, you can see the camera. If the direction of current is inwards, by applying the right hand thumb rule, if the current if the thumb indicates the direction of current, then the closed fingers will indicate the direction of magnetic flux. Then the closed fingers will indicate the direction of magnetic flux. Okay. Yeah, sorry. Then the closed fingers will indicate the direction of magnetic flux, and you can see this direction of this closed fingers are clockwise direction. In that manner, direction of flux is clockwise direction. So okay, this is what actually happens in this portion. Similarly, if you see under the south pole, direction of conductor carrying the current in the outwards direction. So direction of current is leaving. So I need to place my thumb in the direction of current here. As the current direction is leaving, it should be outwards or outside from the board. Okay. Now, what does this curl fingers will indicate? The curl fingers will indicate direction of magnetic flux and in which direction it is there. It is in the anti-clockwise direction. It is in the anti-clockwise direction. So if you combine these two portions here, the resultant armature flux in the center, it is flowing in the downwards. The resultant armature flux, it is flowing in the downwards. I hope already we already discussed a clear explanation here. What we discussed here, how to find out the armature flux in the same manner, just I'm repeating the same here. So here direction of resultant armature flux is downwards. In the same manner, here also just I'm finding that which portion of conducting making the armature flux to move in the downward direction, this third and fourth portion, this corresponding portions of the conductors are making the armature flux to move downwards. Okay. Now, if this flux is moving downwards, what actually happens? So when the armature flux is moving downwards and when the main field flux is direction is towards the right side, the resultant flux is in the cross. And that's what we can see that. And we call it as this is the cross magnetization effect. Am I clear or not? Any doubts? Let me repeat. Due to the effect of these two portions of the conductor, direction of armature flux is downwards. And as the armature flux, direction of armature flux is downwards, and the direction of main field flux is direction of main field flux is towards the right side. Yeah, towards the right side. Due to the effect of this armature flux on the main field flux, there is a resultant flux direction is distortion. Distortion takes place, and this is the resultant. And due to that, we can say that there is a cross magnetization effect is taking place. Now we can conclude that this portion of the conductors are leading to the effect of cross magnetization, and it is clearly mentioned here also. This portion of the conductors are leading to the cross magnetization effect. This portion of the conductors are leading to the cross magnetization effect. Okay. Yeah. So and yeah. And so even we would like to see that then what is the effect of these three conductors which are there in the upward direction and these three conductors which are there at the lower side. Now, as I said that MN axis divides the magnetic region. Towards the left side it is under the influence of North Pole and towards the right side it is under the influence of South Pole. Now all these conductors will be direction of current is inwards as it is under the influence of North Pole. And here all the conductors as it is under the influence of South Pole, the direction of current is outwards. How I am saying that already have repeated that by using right hand thumb rule. By using right hand thumb rule, we got a conclusion that direction of current is inwards or outwards. Now we will try to see this again at this portion at the upwards direction. You can try to see this direction of current is inwards. Now you can see the camera as the direction of current is inwards. What I'm doing here, I need to place my thumb. I need to place my thumb in the direction of current that is inwards, so that the curl fingers will indicate the direction of magnetic field. So here, oh yeah, even I used this symbol in the last class also. So yeah, so here the direction of flux. So the direction of flux is in the clockwise direction. So that just to have a clear idea, I'm showing that at the top it is